Hello, my name is Ben Robertson. I'm the Senior Director of Test Method Development and Analytics at XCMR, and today I'd like to talk to you about our investigation of microbial mitigation in surgical sites using UVC. This work was performed in collaboration with Columbia University, Yale New Haven Health Services, Purdue University, and the University of Colorado Boulder. Quick overview of the study. The overall goal is to identify a UV-based approach to wound disinfection that is both safe and effective, because we believe that the mechanism of action of UV will allow us to target multi-drug resistant pathogens. We initially explored this approach in vitro using 3 different UV emitter technologies and challenging them against the clinical isolate of MRSA. We then moved on to an in vivo study where the top 2 performers were tested in an animal model of surgical site infection. And the end goal of this is to develop a UV-based surgical site disinfection device. But first, the candidate emitters that we explored. There were 3 different emitters we looked at: a UV LED, a krypton chloride excimer, and a xenon flash lamp. These all have different emission spectra shown on the right, and this spectra is what ultimately governs a safe dose for human exposure. So for the UV LED, that exposure limit is 10 millijoules per centimeter squared. For krypton chloride, it is 515 millijoules per centimeter squared. And for xenon, it's around 22 millijoules per centimeter squared. We initially explored the efficacy of these emitters against a MRSA challenge agent that was suspended in an optically clear media. We applied 2, 5, 10, 15, and 20 millijoules per centimeter squared from each lamp. And we saw that xenon was the top performer, achieving the highest levels of disinfection at the lowest doses. The second best performer was krypton chloride, and those 2 emitters were moved into our in vivo study. For the in vivo study, we used a mouse model of hospital-acquired infection, where we applied MRSA to the skin, applied a single dose of UV, and then created an incision at the site of exposure. In this case, the applied dose was 95% of the safe exposure limit. So for krypton chloride, that was 480 millijoules per centimeter squared. And for xenon, that was 20 millijoules per centimeter squared. Despite the huge difference in doses, we actually saw that xenon was still the more effective at decontamination at both day 1 and day 7 time points. This stark contrast becomes even more stark when considering overall decontamination efficiency, with xenon being about 50 times more efficient than krypton chloride. So based on the outcome of these studies, we've decided to move forward with developing a xenon-based disinfection device. We're currently considering handheld and overhead form factors. I'd love the opportunity to discuss this with anyone who's interested. Please come by the poster. I look forward to seeing you in Orlando, and thanks for your time.